Hi guys. What we're going to be doing today is going over a couple of the worksheets that I just posted to Google Classroom as your assignment. And my intention is for you to leave this session with just a better feel and understanding for both air masses and fronts. Be forewarned, fronts is a difficult topic. This is something you might need to go back and watch videos for, maybe more than once. Maybe check out the MetFan videos. There's a few others that I would recommend as well. Again, if you're struggling, please shoot me an email, but don't do that first. Make sure you take your time and watch the videos that we posted already, as well as to attempt the assignments and then give it a shot. The second thing I would say in the same department is you should not be starting this video unless you've gone and watched the others first. This is more of a review and how do we do the questions, not so much a take notes and first, learn and understand and introduce the concept. All right, without further ado, I'm going to start with a couple of things. The first one is I'm going to jump right into air masses. Now, in air mass, we have to focus on what a source region is. This is the place where it comes from, and it gives its characteristics. So, for example, right, if we look at number one, this is going to be pretty far north, and it's out over the water. All right, this is the continent, so this is out over the water, and because it's far north, it's not tropical, but it's cold, and we refer to that as polar. If it's super duper cold from very far north, we might call it Arctic, but that's rare. This is also over the water, so we wouldn't call it continental, we would call it maritime. So this should be lowercase m for maritime, capital P, M, so lowercase m, capital P for polar, MP. We'll jump down here to the bottom. Let's do this one that's over kind of Texas / Mexico. And what we'll notice is we're ignoring where the arrows are. That's just where it's headed. And it's formed, right? Its source region in this case would be kind of Texas / Mexico. So we know that it's in a warmer environment, so tropical, and it's over land. So this should be a CT, a lowercase c, capital T. This is kind of how we do this. An air mass is just, a general region of air, parcel of air, very large, that is all going to have the same or uniform characteristics, specifically referring to both temperature and amounts of moisture. Okay, so when these two things meet, two different air masses, we get what's called a front. And what that's going to look like is this. So cold front's going to be this on the left side of here. Cold, we have the cold air. It's nice and steep in the front. Warm air rising. Notice that arrow is pointing up at a very steep angle. That's because the warm air is less dense, therefore it's rising along the front. And of course, we know anytime we have mixing of warm air, cold air, rising air over a front, we know this is where we're going to get our precipitation and our low pressure. So actually, the day that I'm recording this, we actually had a little bit of a thunderstorm front come in. A warm front previously, and then we had a cold front make its way in. Cold fronts tend to move relatively quickly, and they drive that warm air up very fast, and then we can get things like lightning, which we did have today, and we get things like thunderstorms. Warm fronts are going to be at a much more shallow angle. They move slower. That warm air does move up, so we still get that cooling, expansion, condensation, cloud formation, and precipitation, very likely. So, but more like light over a long period. This is like heavy over a short period in the cold front. If a cold front catches up to a warm front, we get what's called an occluded front, where they kind of combine. So cold air jumped up, made it to combine with the warm front here. Just to be clear, the cold air is underneath this line, the cold front, because it's more dense. The warm air is as high as it can be here, and then it's also above the cold. And this area is actually cool. This is cold air. But this thing is the the warm front, where the warm air is meeting the cold. Okay, so let's take a look at what some of this should be on our worksheet. So what are these air masses? Well, this is CP, so that's continental polar. This is the cold air mass. So I would say cold and warm, right? This is a warm air mass, right? Maritime tropical. Okay. What's the name of this front? This is a cold front, right? Because this is the steep, fast-moving, high angle. We've got an anvil cloud, also known as a cumulonimbus cloud. I would know those terms, which is just referring to a thunderstorm cloud that's formed at a cold front. Is precipitation going to be heavy for a short period or steady for a long period? At this location, it will be heavy for a short period. Look at that quickly rising air. And okay, we're just naming fronts. Nice and easy. Let's jump. And let's take a look at a couple of these. What type of front is represented by X? Okay, that's the same question. We have steep, we got cold air. I think you know that's a cold front. We're going to get heavy precipitation. Why does warm, moist air rise? It's less dense. Same reason anything rises or sinks. 3, which type of front forms when X catches and overtakes Y? So this X catches up to Y and they combine. It was a picture I showed you before, what we call occluded. 4, what geographic region is most common to get a maritime tropical air mass? That would be the Gulf of Mexico, right? M, maritime over water, T, tropical, someplace warm. It's the only one that fits that description. 5, what weather variable will decrease ahead of a storm? Well, would wind speed decrease? No, they would increase with a storm. Air pressure would decrease because low pressure, lousy weather. Low pressure means we have rising, warm, moist air versus cool, dry air that's sinking, which would be high pressure and good weather. Cloud cover you're going to get more of. Humidity you're going to get more of. Okay, so we take a look at this whole thing. We've got a dry line here, whatever that means. Okay. We have to fill this in. I'm going to trust that we know station models for now. Let's do some of the tougher questions. 7, compared to the temperature and humidity on the east side, describe the temperature and humidity on the west side. So we look, and this number gives us our temperature, and this number gives us our dew point. So here we've got 2 that are close, so that's high humidity. Here's that are 2 that are close, that's high humidity. Here's another 2 that are close, that's high humidity. Not to mention, the station models have a filled-in circle, meaning 100% cloud cover, overcast, very humid. So the right side's very humid, the left side is dry. These numbers are far apart, and we have a blank slate in the middle there. So now I got to go back to the question, what's going on? Describe the temperature and humidity on the west side. Okay, the temperature is lower because the numbers are lower, and the humidity is also lower because they're further apart. Why does warm, moist air rise? We already did this. Number 9, in what compass direction will this move if it follows a normal storm track? Well, the truth is we really haven't done the normal storm track yet. What we can do is this. This isn't going to be too tough to see. We're going to look at, let's get a little USA map going on. Basically, it's the idea that we have what's called a jet stream in the United States. The jet stream is a general movement of storm systems and air masses from west to east. Now, in the west, the truth is it's not just west to east, because when we look at the west side of our country, it's more of a southeast. Then it kind of turns into an east. And then by the time it gets to New York, it's kind of a northeast. Here's another image that really gives us a better idea. Now, it does change from time to time, but generally speaking, this is our jet stream. And during the summer, it warms up, and this whole jet stream gets pushed further north, and that cold area tends to dissipate and move itself further north. Whereas in the winter, and this is the very extreme version of this is what we refer to as the polar vortex. That's where we have a super one of these. You'll get the cold air really pushes down. This whole bit drops much, much further down, and it looks a bit different. Again, you'll see these things can change over time. This is a late August version, right? And then here, of course, is a December version. So it does move, but generally west to east. And notice when we're in New York, it's kind of a northeast. Let's go back to the question that we just had at hand. It's going to move, the storm system's going to generally move to pretty much a northeast. So I like northeast for number 9. Number 10, an air mass classified as CT usually forms over what surface? So C is continental, so land, and T is tropical, so warm land would be 4. Cloud formation occurs in rising air because it expands and cools. We should have covered this concept already. Skipping this question. Actually, no, let's not. We have this symbol, which is going to mean snow. And I'm going to pick a cold one that looks humid. So not this one. This is humid, but not cold. So I think this one would make sense. These two are close, full cloud cover. And that symbol means snow, according to your reference table. Finally, 13. Where do you get air mass B? Well, air mass B is warm and moist. Where do you get one of those? What's a source region? I think Gulf of Mexico is a good one. 14, what's the type of front shown between B and C? See the shape where the warm air is slowly going up this side and it's kind of shallow? That's a warm air mass. Finally, 15, one process that forms clouds, that's condensation. Guys, if you have questions, let me know. Have a great day.